Most people probably don't acknowledge what peatland does. It's a living landscape. It's got carbon captured underneath in the form of the peat, and it will continue to gather carbon from the atmosphere as it grows. And once you break that cycle, when you get degraded peatland, it then releases all that carbon back into the atmosphere. We're talking megatons of carbon. With peatland restoration, if you restore it back to a near natural condition, it starts to sequester carbon again from the atmosphere. The Glendevon complex is made up of 5 different reservoirs which feed into the Glendevon water treatment works, which then services quite a bit of Fife for their water supply. The Sustainable Land Management team have got an objective to assess every single drinking water catchment for peatland restoration potential. That covers about 400 catchments feeding about 230 water treatment works and covers about 500,000 hectares. We're looking for any reduction in dissolved organic carbon coming into the water treatment works. The peatland is starting to dry out. It's in a degrading situation. All that carbon that's been stored over a millennia or more then starts to get released back into the atmosphere. This peatland is drying out. There's nothing to hold the water back. We've got exposed surfaces, and the water action from rain and wet weather events will just keep stripping this peatland out of the site and away down into the reservoir, which is the thing that we're trying to avoid here. Once it's lost, that's it, no more. And once you get to the bedrock like it has here, you've got an incredibly difficult job to try and get peatland to grow back on that bedrock. We have seen situations where it's so fine and dusty with the wind, and you've had a particularly long hot summer, it can then just start to blow off like the Dust Bowls of America.
How old is this stuff?
It's very difficult to determine. We'd have to take a core to find out how deep that peat is.
This here is called a Russian peat corer, so we're going to try and take a core and just to see what condition it's in. Okay. Peat is typically laid down at 1 millimetre a year, so it's giving you a snapshot through time. Okay, and there we go. This is a peat core sample that we've just taken. We've probably taken a sample from about 1.8 metres deep, so you're actually taking a journey back through time. This is probably from about 1800 years ago, and at the top of the core here, you're probably looking about 1500 years ago.
Quite a bit of water in it. A healthy peatland will operate in an anaerobic state where there's a lack of oxygen, so it actually preserves anything that's inside that peat. So you can see here all these little roots, which potentially could be hundreds if not 1,000 years old or more. But once that peatland degrades and is exposed, these little roots and everything else will start to decay, and that's when you get a release of carbon into the atmosphere. So what we've got here is an erosional feature called a peat pipe. The water will flow down the edge of this badly degraded peat. As you can see, it's gone right down to the bedrock. Hydrology pressure, as it tries to find a way through the peat, creates this pipe that can go on for several metres through the peatland until it finds an exit on the other side. Very difficult to restore because it can be very vulnerable on top of the peat. So as the machines come in to restore the peatland, they have to identify these peat pipes and avoid driving over them, otherwise the machine will fall through. We bring the machines in to start restoring peatland. We have a number of activities to do. First thing we're going to do is reprofile the hags. We will cut away the peat there to allow the vegetation to then rejoin the gully, and that will knit that together. The next thing is to block up the gullies, the drains, any natural or unnatural drains. That's called grip blocking. That stops the water flowing and starts to push the water back, which will then raise the water table. The next thing we'll do is create little pools and ponds, and then we'll reseed those pools and ponds with any donor sphagnum moss we have on the site. We've got several projects. One project up in Sandy Loch in Shetland, where we did the gully reprofile and the hag reprofile and the grip blocking, the pooling, the ponding, and we've done some reseeding up there as well. That had a noticeable rise in the water table. It's actually been quite incredible. We didn't really appreciate how quickly that water table has risen. These pools that we look for in really good condition peatland filter the water. They hold the water back through the sphagnum moss, which can hold up to 30% of its weight in water, and then it stores the water and slowly releases it into the reservoir over time. So it has the effect of mitigating against drought and possible wildfires as well. So filtering the water, creating high quality source water before it goes to the reservoir, holding the water back and mitigating against any drought conditions we might have. Because we've had very little rainfall, it's still holding that water back.
Yeah.
If you actually walk into the pools, you'll find that if you pick up some of the sphagnum moss, it's still full of water, so it's still acting as it should. If this was not a good condition peatland, that would be a much drier situation, releasing lots of organics into the reservoir. We can take some of the sphagnum moss from here and throw it into the pools that we've just created, which will then start to grow within those pools and then act as that filtration and that sponge. And that will then raise the water table and just make the whole peatland come alive. You can expect to see some significant regrowth after about year 5 post-restoration. For every year, for every hectare, you can take several cars and buses off the road if that peatland is in a healthy growing condition.